Yeah, good afternoon, everybody. We'll start with an SEN class now. In the last class, we had discussed how the symmetric method of an cryptography will be there and how what are the different types of an asymmetric cryptography, that is DES algorithm, and coming to the triple DES, how it will works and how in a symmetric algorithm a single private key will play the role, means how that particular key will encrypt and decrypt. And coming to the next thing, we have discussed the EES algorithm, also advanced encryption system. So that also we had discussed, and we have seen in that how the 128 bit key will play a very much important role. Coming to the next thing, the public key exchange or a public cryptography, and in other words, asymmetric cryptography system, which we have seen in that two keys will play the role. One is in a public key and another one is in a private key. So the public key will be shown always to the users. So the user who wants to send in a data, he will take that public key and he will encrypt the data and he will send the data, and the receiver who receives the data will use the private key which is meant only for him, and he will decrypt that particular message. Then we have learned like this, what is a how you can define that public key will belongs to only this particular person. So we have discussed the certificate authentication or authority body CS, we have discussed, and then how that particular authentication will be done, and what is the use of a digital signature and how a hash function will be used. So SHA1 and SHA2 also we have discussed how a digital signature is very important in that particular terms, and through that certifications or a certificate of authorities, how it will define that this public key and based on this particular credentials, this public key belongs to so and so person. And we have taken a real time examples in a last class, like how a mobile voice will be encrypted and it will be reached to the destination, that we had discussed. And bank transactions, we had discussed what is the importance of OTP and how the OTP will play the role, one time password, in a real time examples comparing with our theoretical concepts. We had discussed that particular thing. And another one important concept which we have discussed in our last class is a redistribution of a keys for a symmetric cryptography systems. How a private key, single key will be there in a symmetric, how that key will be exchanged or it will be distributed to both the users at that particular time. So for that, Duffy and Hellman algorithm, how it is going to work, how a prime number P will be taken into the considerations, and how a K can be defined. That so that is to the P to the power of K mod of N. So how the algorithm will take that shape into the consideration, and how we are going to transfer define a key with that particular sense. So that we had discussed in our last class. Now, based on all this concepts, I am going to conclude like this. So the computer network security system is very much important in this particular things. The information which should be transferred from the source to destination will be encrypted, and it will be decrypted. Now, coming to the next topic in our particular syllabus, we are going to see how a firewalls will work. The firewalls is the one particular thing where we can stop the particular packets coming into your particular network, and you can define that particular firewalls. So this particular IP address packet shouldn't be there. For example, I will tell you, any prone websites things we don't want to allow into the BMSIT campus, then we can adapt a firewall at a BMSIT internet data center, and we can make that websites or that IP address based websites can be blocked. That packets can be blocked in our things. Then we will see how firewalls will work, and what are the different types is there. We are going to discuss in this particular session. Now I will share the PPT. Yeah. Now coming to the firewalls. A firewall is a system that typically sits at some point of connectivity between a site it protects and the rest of the network. It's usually implemented as an appliance, means on application or a part of a router. Although a personal firewall may be implemented on an end user machine. So there will be different types of firewalls which can be there at a network level or it can be there at an application level also. Firewall based security depends on a firewall being the only connectivity to site from outside. There should be no way to bypass the firewall via other gateways, wireless connections or dial-up connections. So this is very important that once you want to install a firewall, you must make your entire network should pass through only this particular gateway where the firewall is going to be installed. So that confirmation should be there. In effect, a firewall device divides a network into a more trusted zone internal to the firewall and a less trusted zone external to the firewall. That means assume your firewall will be there and firewall is connected to the outside network. So apart from that, the outside network is insecure. Apart from this side, whatever the firewall is there, your network BMSIT is there. So that is a trusted zone. This is useful if you do not want external users to access a particular host or service within your site. So firewall may be used to create a multiple zones of trust, such as hierarchy of increasingly trusted zones. So based on your particular things, you can create a different zones for a trusted. So these websites will be used only in this particular zone, and these websites will be only for that particular zone. Like that, you can make a firewall. So a common arrangement involves three zones of trust: the internal network, the DMZ, delimiterized zone, and the rest of the internet. So in between zone and rest of the zone. So usually there will be a three zones will be there. Now firewalls filter based on IP, TCP, and UDP information among others. So they are configured with a table of addresses that characterize the packets they will and will not forward. So by addresses, we mean more than just the destination's IP address, although that is one possibility. So how a firewall will work? Whenever a packet will come, the firewall will check its particular IP address and port addresses. So first it will check its IP addresses. So this IP address in already in a list it has been banned. So then automatically that packet will not be allowed into the network. So based on a port number also, it will generally each entry in the table is a 4 tuple. It gives the IP address and the TCP UDP port number for both the source and the destinations. So based on that particular two things, there is a port number and IP address, your firewall will detect so whether this particular packet can be moved in a trusted zone or not. So coming to the next, you observe this particular figure here. Remote employee of a company is a random external user is there, right? So the fellow is working from home, or work at home option. Now this particular era, you know that because of the coronavirus, how the work at home option for a company is compulsory. Then how trust you can allow the company site or a company server to the public internet. So how they are going to do this particular thing? The company will have a very big and very efficient firewall will be there. A firewall filters packets flowing between a site and the rest of the internet. Assume this is a company, through internet the packets are coming. So here the firewall will detect which is the random external user packet and remote employee company packet. So based on that, this random external user packet will not be allowed and only the remote employee packets will be allowed into the company website. So in this way, the firewall will works as an wall to that particular company. Now coming to the summarization of the of the fifth unit. So that is we discussed privacy and security issues in a network. We have discussed different authentication protocols. We have discussed different key distribution protocols. We have discussed different cipher techniques, classical and public also. And according to your syllabus, you don't have this PHP, SSH, and IPsec. So that's why it's not discussed there. So all these above things we had discussed with the firewalls also. So now coming to the next topic, that is what is the traditional applications in a computer networks that we are going to discuss in a coming session. Now coming, I'll stop this. We'll go back to that particular things. Just 1 minute. Yeah, just we'll share the new topic now, the applications back here, and this is the last topic which we are going to discuss for this computer networks subject. Now coming to the applications. Now finally we'll see how applications will play the role and what are the different types of applications in that, how a traditional applications will be worth to be seen, and that means will be useful and how we can use that particular thing. Applications need their own protocols. This is very much important. So based on your application protocol should be working. For example, I will tell you like this: I'm browsing. So then I need one browser where websites www dot so websites can be opened. So how this particular means how these applications will work is based on HTTP. So that is a one particular protocol which is needed for an application thing. Then, for example, assume I'm using an emails. I want to see open emails and I want to read my particular mails. I want to send a mail. SMTP, that is shortest message transfer protocol, sorry, which is an application protocol which is very useful there. Like this for telnet, and coming to the file transfer FTP, like that different application protocols will be needed based on their applications. These applications are a part network protocol, that is in the sense that they exchange messages with their peers on the other machines. Very important this is. For example, I will tell you like this: if I send a mail to my particular any of my friend, he must open that particular mail and he has to see. That means if SMTP protocol will be used by both the host, the sender, and as well as a receiver. So website also same thing. That is, if server is there where the website contents has been loaded, and a browser must be there. So where I can give and the www.dsn name, the domain the network system name, the DSN name, server name can be given there, domain server name. So internet will be converted to the IP address, and that particular server connection can be established using HTTP. Like that, both the user and a destination, they must know which particular protocol they are using. And a part, a traditional application program, that is in sense that they interact with the windowing system, the file system, and ultimately with the user. So this chapter explores some of the most popular network applications available today. Now coming to this, what we are going to discuss: traditional applications, multimedia applications, infrastructure services, overlay networks. In this, according to the syllabus, the traditional applications plays a very much important role for our exams and then second semester computer networks. Coming to the traditional applications, two of the most popular traditional applications are there, that is www and email. Usually you know this. So what for we'll use the internet? Almost all 90% of the internet will be used to search some particular websites information. We are going to search from that particular websites and all. So where www World Wide Web plays a important role, and we want to translate a message from one place to the another place. So where email will be very much useful. So these two most important things is that, broadly speaking, both of these applications use the request reply paradigm. Very simple. So if I want some particular information, as if I want an information of some particular motorcycle, just for a sake, I'm going to tell you what usually I will do. I will go to that motorcycle company, for example, www.tvs.com. For example, I'm going to tell I want to see some TVS motorcycle details and all. So when I will type that, I'm requesting. So here as a client, as a user, I am requesting the TVS server that I need this particular information of you or your website information, where a server will be there. It will reply. It will give the reply to us. So that's why here the HTTP protocol. So the hypertext transfer protocol, where request with the request and reply functions is going to work. Users send requests to servers, which then respond accordingly. Now coming to the next thing, it is important to distinguish between application programs and application protocols. This is very much important. So application programs is the one where we are going to develop an application. So application protocol is the one where it is useful to transfer the information from one peer to the another peer at that particular level. For example, the hypertext transfer protocol HTTP is an application protocol that is used to retrieve web pages from a remote server. So we know that. So there can be many different application programs, different application programs may be there. That is web clients like Internet Explorer, Chrome, Firefox, Safari, like that. Different browsers may be there. That are the applications or application programs that are there, that provide users with a different look and feel, but all of them use the same HTTP protocol to communicate with the web servers over the internet. So of these, of any browsers, if you are going to take, all browsers in a default will use the same the HTTP protocol to communicate with other web servers. Coming to the next, two very widely used standardization application protocols, that is SMTP, that is simple mail transfer protocol, is used to exchange electronic mails. So from one system to another system, if you want to transfer a message or an email mail from one system to the another system, the main protocol will be useful is SMTP. And another one is to browse or to connect to the web servers, we are going to use HTTP. Hypertext transfer protocol is used to communicate between web browsers and web servers. Web browser is the one where client will use, web server is the one where data will be stored. Coming to the next thing, electronic mail, SMTP or MIME or IMAP, these are the protocols which will be used in to transfer the message from one system to the another system. So email is one of the oldest network applications. It is important. First one, to distinguish the user interface, that is your mail reader from the underlying message transfer protocols such as SMTP or IMAP. And the second one, to distinguish between the transfer protocol and a companion protocol, that is RF822 and MIME, that defines the format of the message being exchanged. This is very much important. The two protocols RF822 and MIME will tell which format you can send the message. So you can't send as you want. For example, I will tell you like this: you can't send like a Word or Excel, something different office formats which you have seen. The electronic mail will have its own format. That is to whom it has to send the CC and BCC, and then what is the matter body and where the stamping should be there. So this is the structure of that particular body where these two protocols, that is RFC 822 and MIME, will decide. And SMTP and IMAP, any one of this protocol, what it will do, it will take a responsibility to transfer that formatted, that type of structured message from source to the destination. So in this way, this protocols is going to work. Now message format. Now RFC 822 defines the messages to have two parts. One is a header and another one is a body. Both parts are represented in ASCII text. Originally, the body was assumed to be simple text. This is still the case. Although RFC 822 has been augmented by the MIME to allow the message body to carry all sorts of data. So in beginning, RFC 822 is meant only to transfer a text messages as a mails. Then what a MIME has did in that particular thing, this is a one protocol which taken all sorts of data, either it's a audio, either it's a video, whether it's whatever type of data, picture vertical data, whatever giving all data sorts of data is considered in a MIME. So this data is still represented as a ASCII text, but because it may be an encoded version of say a JPEG image, it's not necessarily readable by human users. The message header is a series of CRLF, that is terminated lines. So standards of carriage written plus line fed, which are a pair of ASCII control characters often used to indicate the end of a line of a text. So in this way, the header will be represented. So message format. The header is separated from the message body by a blank line. Each header line contains a type and value separated by a colon. Many of these header lines are similar to the user since they are asked to fill them out when they compose an email message. That is to whom to send CC copy, BC copy and all. So RFC 822 was extended in 1993 to allow email messages to carry many different types of data, audio, video, images, PDF documents and so on. Then it will be converted to the MIME. So MIME that is consists of three basic pieces. What is that? The first piece is a collection of header lines that augmented the original set defined by a RFC. So what the textual lines is there, that is needed. These header lines describe in various ways the data being carried in a message body, what type of data. They could mime the versions, the version of a MIME being used in that, content description, what actually this content will be there, and content type and content transfer encoding, which type of encoding has been used. The details will be there in a header. The second part, what will be there in a MIME, the second piece is definitions of a set of content types. For example, MIME defines two different still image types denoted as a GIF and a JPEG, which with the both obviously meaning. The third piece is a way to encode the various data types so they can be shipped in an ASCII email message. So whatever various data you have fixed, everything will be converted into the ASCII format, and that ASCII, based on that ASCII, the encoding will be done and it will be taken in a third piece. So now then message transfer. So how a message transfer will be done? For many years, the majority of the email was moved from host to host using only SMTP. Now SMTP will come into picture. While SMTP continues to play a central role, it is now just one email protocol of a several. That is, so how SMTP will work. So IMAP and POP, POP being two other important protocols for retrieving mail messages. Now, to place a SMTP in a right context, we need to identify the key players. So first, users interact with a mail reader when they compose a file, search and read their mails. There are continuous mail readers available, just like there are many web browsers to choose from. So every person should have a mail account, and particularly a mail reader must be there. That we'll call it as a Google, Yahoo and all. In early days of the internet, users typically logged into the machine on which their mailbox resided, and mail reader they invoked was local application program that extracted message from the file system. So in the previous days and all, the whatever, it's not with a browser. So it is meant with one particular system where user wants to check a mail, means he must go to that particular system and he has to check the mails which has been stored in an external hard disk of that particular system. Today, of course, users remotely access their mailbox. This is important. Remotely access their mailbox from their laptop or a smartphone. They do not first log into the host that stores their emails. So each and every, with the authentication process, each and every person who is having a mail account, they can log into their mail account. Now they can see their mails remotely also nowadays. So coming to the next, to place a SMTP in a right, we need to identify the kill. Second, there is a mail daemon will be there running on each host that holds a mailbox. You can think of this process also called a message transfer agent. So this is a one person who will transfer a message from one system to the another, as playing the role of a post office users. So as if a postman give the daemon messages they want to send to other users. The daemon uses SMTP running over a TCP to transmit the message to the daemon running on another machine, and the daemon puts incoming messages into the user's mailbox. So where that will be taken into the consideration. So since SMTP is a protocol that anyone would implement in theory, there could be a many different implementation of the mail domains like that. So message transfer agent will play a very much important role to transfer the protocol. While it is certainly possible that the message transfer agent on a sender's machine establishes an SMTP connection, means with the help of an TCP, the MTA on the other recipient's mail server, in many cases, the mail transfers one or more mail gateways on its route from the sender's host to the receiver's host. So how, for example, assume I am using a Google Gmail and I have opened a Gmail, and after typing all my message, everything, I have pressed a send. Once I pressed a send button, my messages, whatever is there, will be taken by my MTA. That is a message transfer protocol, means that will be taken, agent will be takes that particular message and he will goes to the gateway. In a gateway you will see to whom the mail address is addressed. So for example, assume I am addressed to Yahoo Mail. So definitely through the gateway that will be given to the Yahoo Mail server. Then there the message transfer agent of Yahoo will be there. He will take that particular mail and he will cross check whether this particular mail is belongs to his particular server. That means Yahoo. So all the mail addresses of the Yahoo with the send mail address will be checked. Assume that mail address is not there, then it will be bounced back. So then what your MTA will text, it will give you as a bounced back error message where this mail address is not there. Assume that the mail address is there already existing. So then what happens, the Yahoo MTA will say, yeah, this is existing. So then it will take that particular mail where each person will have his own database or his own user space in a mail. So or a mail reader. So what they will do, they directly based on the name of that particular email. So where a space is open in that inbox, the mail will be transferred. So whenever the user again opens the inbox, automatically you can read that particular mail. So in this way, the MTA will play a very much important role in the things. Like the end hosts, these gateways also run a message transfer agent process. It is not accident that these intermediate nodes are called gateways, since their job is to store and forward email messages, much like an IP gateways. Coming to the next, message transfer. The only difference is that a mail gateway typically buffers the messages on the disk and is willing to try retransmitting them to the next machine for several days, while an IP router buffers degrams in a memory and is only willing to retrieve the transmitting. So here it's not a real-time thing, especially when we are dealing with the mails and all. So once if a delay occurs, if somewhere it will be there, then what happens in between the systems, whatever will be there, they will store that particular messages in a disk and later it can be retrieved. So mail reader, what is a mail reader? The final step is for the user to actually retrieve his or her messages from the mailbox. So this how? For example, read them, reply to them, and possibly save a copy of for a future reference. The user performs all these actions by interacting with a mail reader. Mail reader is something like our mail server, like Gmail, Yahoo Mail, like that. As pointed out earlier, this reader was originally just a program running on the same machine as a user's mailbox, in which case it would simply read and write the file that implements the mailbox. This was the common case in the pre-laptop era. Now, coming to the next, continuing with a mail reader. Today, most often the user accesses his or her mailbox from a remote machine using yet another protocol such as POP. So, how you can open the mailbox and all, either you have to use Internet Message Access Protocol, that is IMAP, or you can use POP, that is Post Office Protocol. That means to open a inbox and to read. For that, these protocols will be helpful. It is behind the scope of this book to discuss the user interface aspects of the mail reader, but it is definitely within our scope to talk about the access protocol. So how you are going to access that particular message. So IMAP is similar to SMTP in many ways. So there a sender, how it's going to send, it will be same like that. It's a client server protocol running over a TCP where the client issues commands in the form of CRLF terminated, means lines, ASCII text lines, and the mail server running on the machine that maintains the user's mailbox response intel. For example, Gmail, www.gmail I will type, I will enter my mail address and the password, then authentication will be done. The exchange begins with the client authenticating him or herself and identifying the mailbox he or she wants to access. So which mailbox I should access? The mailbox, when I have created an email, my mailbox is created. So mailbox means a user space in that particular server. For example, if I create a Gmail, my space will be there. My user space will be there in a Gmail server. So to access that, I need an authentication. Once it has the authentication process has been done, then access will be given to particularly the mail. So how this process will be done, you can see here, the connection establishment will be there, server greeting will be there. So first one, not authenticated. When it is not authenticated, directly log out, or next it will go, again it can tell authenticate once again. So once assume that selected, you have authenticated, then again it will ask you authenticate. So most probably your authentication has been done, log out. Both sides close the connection. So in this way, once it has been selected, see here, successfully selected or examine command, then automatically it will goes to the mailbox. So in this way, you can observe that particular flow chart. Then World Wide Web. We'll come to the next thing. The World Wide Web has been so successful and has made the internet accessible to so many people that sometimes it seems to be synonymous with the internet. So internet means World Wide Web. There's no other name. Actually, we'll feel like that. Nowadays, we are getting internet is for many things, but in sometimes we'll feel like that internet means tell me the website address. So www dot something. So then internet. So like that, it became the world of a web. In fact, the design of the system that became the web started around 1989. Along after the internet had become a widely deployed system. The original goal of a web was to find a way to organize and retrieve the information, drawing on ideas about hypertext interlinked documents that had been around since at least the 1960s. I will keep my data in one particular system. I need some web pages or hypertext lines where that contents can be retrieved in another system as a client and they can see that particular thing. The core idea of hypertext is that one document can link to another document and the protocol HTTP and the document language HTML. Underline this. The HTML, hypertext markup language, were designed to meet the goal. So one helpful way, which you have studied already in your web subject. So one helpful way to think on a web is a set of cooperating client servers, all of whom speak the same language HTTP. That is request and a reply that you can do using an HTML. Most people are exposed to the web through a graphical client program or a web browser, so which you are going to use your HTTP to run your HTML codes there. So that programs is needed. That is Chrome, Firefox, or Internet Explorer. Clearly, if you want to organize the information into a system of linked documents or objects, you need to be able to retrieve one document to get started. So a main page or indexed page should be there first, where interlinks will be there from one page to the another page where information can be dragged. So that means that the one master page or one home page is well needed, always with some particular address. Hence, any web browser has a function that allows the user to obtain an object by opening a URL, Uniform Resource Locator. Underline this particular thing. Yeah, so whatever www.google.go.in if you give, sorry, co.in, whatever if you give, so that is an URL. www.yahoo.com, www.youtube.com, whatever you are going to give. So that are the URLs are so similar to most of us. By know that it's easy to forget that they haven't been around forever. So we can remember as human beings, we can remember the words easily rather than the numbers. So if I tell you that you must remember the YouTube or any Google or any other servers using only their IP addresses, that 172 or 168.10.16 something like that, then you will tell, sir, no, I can't remember. So how many web addresses can I remember like that? Okay, URL will be there, other name you can remember. They provide information that allows objects on the web to be located, and they look like the following. That is http www dot the name. So if you open that particular URL, your web browser would open a TCP connection to the web server at a machine called www.cs.princeton.h, and immediately retrieve and display the file called index.html or homepage.html. So this is one important thing. What your TCP will do? Your TCP will establish a connection with that particular server. Most files on the web contain images and text, and many have other objects such as audio and video clips, pieces of code, etc. They also frequently include URL that point to the other files that may be located on other machines, which is the core of the hypertext part, HTTP and HTTP. Now, so how the HTTP will be taken into the consideration. When you ask your browser to view a page, your browser fetches the page from the server using HTTP running over the TCP. Like SMTP, HTTP is a text-oriented protocol. At its core, HTTP is a request response protocol. I'll request, you give response, where every message has a general forum. So that is a start line, end of the line, message header, and you have to close that tag. Body of the message will be there. This HTML tags you have seen in your web subject. So coming to the next, request messages, how you are going to check. The first line of an HTTP request message specifies three things. The operation to be performed, the web page the operation should be performed on, the version of the HTTP which you are going to use. So in that three things you are going to request. Although HTTP defines a wide assortment of possible request operations, including write operations that allow a web page to be posted on a server. So post function will be there. The two most common operations are get. So fetch the specific web page, and add. So fetch status information about the specified. So get function will be there. So request messages, whatever is there, options, get, head, post, put, delete, trace, connect. I think you have already learned these things in your web subjects or introduction to the web. In that particular subject, you have learned already this one. Then response messages. What are the response messages will be there? So like request messages, response messages begin with a single start line. In this case, the line specifies the version of HTTP being used and three-digit code indicating whether or not the request was successful, and a text string giving the reason for the response. So what are those things? Informational, success, redirectional, client error, or a server error. So explanations will be there. you can see. So informational request received, continuing process, success, action successfully received, understood and accepted, redirection, further action must be taken to complete the request, error, so error message is going to give. Now, uniform resource identifiers, about that we'll study something. The URLs that HTTP uses addresses are one type of the uniform resource identifiers. So that is URIs. The URI is a character string that identifies a resource, where a resource can be anything that has identified, such as in a document, an image, or a service. The format of URIs allows various more specialized kinds of resource identifiers to be incorporated into the URI space of identity. The first part of URI is a scheme that names a particular way of identifying a certain kind of resource, such as Melito for email address or file names. Sorry. The second part to identify information. The second part of URI, separated from the first part by a colon, is the scheme or specific part. So how a TCP connection will be established. The original version of HTTP, now today we are having 5, so now 1.0, establish a separate TCP connection for each data item retrieved from the server. It's not too hard to see how this way a different insufficient mechanism, connection setup and tear down messages had been exchanged between the client and server, even if all the client wanted to do was verify that it had the most recent copy of a page. Thus, retrieving a page that included some text and a dozen icons or other small graphs would result in 13 separate TCP connections being established and closed. To overcome this situation, in a version 1.1 introduced a persistent connections, which we have discussed already while discussing a TCP, the persistent connection. The client and server can exchange the multiple request and response messages over the same TCP connection. Once it has been established until terminations, so many requests and responses can be done. So persistent connections have many advantages. So you can go through that. Now, how these things will be there, how a connection, TCP connection will be established, a sync message will be sent to the server, that sync message will be acknowledged, then HTTP get connection means get request will be sent, so HTTP response will be sent, and final message, yeah, it's okay, it will be sent, again sync will be sent. So like this is finalization of the connection. So client processes the response. So again, server processes the request like this. Once the connection is established, so traditional then how these things will be work. HTTP get will be there, HTTP response, again HTTP get, HTTP. For each and every website, these things will be keep on going. And then catching of websites. So one of the most active areas of research and entrepreneurship in the internet today is how to effectively catch the web pages. Means how to arrange, how to place the web pages in a memory. Catching has many benefits from the client's perspective. A page that can be retrieved from the nearby cache can be displayed much more quickly rather than coming from a big server, which is a far place. For the server's perspective, having a cache intercept and satisfy request reduces the load on the server. So that's why they are using a cache. Caching can be implemented in many different places. For example, a user's browser can cache recently accessed pages and simply display the cached copy if the user visits the same web page again. As another example, a site can support a single site-wide cache. This allows users to take advantage of pages previously downloaded by the other users. So closer to the middle of the internet, the ISP providers in between, they can maintain a cache in their servers, so which frequently used websites, for example, Google.com and previous that suddenly used some frequently used such things, web pages, details, it can be there. So much of the motivation or enabling the direct application to application communication comes from the business world. Historically, interactions between the enterprises, businesses, or other organizations have involved some manual steps such as filling out an order form or making a phone call to determine whether some product is in stock. Even within a single enterprise, it is common to have manual steps being between software systems that cannot interact directly because they were developed independently. Increasingly, such manual interactions are being replaced with the direct application to application interaction. Today, the world of e-commerce has been came into existence, and the transactions how it is going on today. An ordering application at an enterprise A should send a message to an order fulfillment application at enterprise B, which would respond immediately, indicating whether the order can be filled or not. So perhaps if the order cannot be filled by B, the application at A would immediately order from another supplier. So two architectures have been advocated as the solutions to this problem. Both architectures are called web services, taking their name from the term for the individual applications that offer a remotely accessible service to client applications to forum and network applications. So word is very much important. The terms used as a informal shorthand to distinguish the two web services architectures are SOAP and REST. The SOAP architecture's approach to the problem is to make it feasible, at least in theory, to generate a protocols that are customized to each network application. So the key elements of the approach are a framework to the protocol specifications, software toolkits are automatically generating protocol implementations from the specifications, and modular partial specifications that can be used across the protocols. So how many suite of protocols or a set of protocols will be used, and one by one everything will be taken into together by so. Then coming to other one, the REST architecture's approach to the problem is regard individual web services as worldwide resources identified by URIs and accessed via HTTPs. Essentially, the REST architecture is just the web architecture. The web architecture strengths included the client server architecture that so included the stability and demonstrated scalability. So then in a traditional things you can see custom application protocols which is not there in a syllabus. So further you can. So this ends your syllabus of the computer networks for this semester, this academic semester. Each and every topic in this particular computer networks we have discussed. Just I'm going to conclude you. So how I had made the entire syllabus, how we have traveled, and what are the important things once we will discuss now. So just 1 minute. Yeah, I will share again. Yeah, you can see the unit 1 we have discussed applications, requirements, network architecture, and implementing the network software and its performance. So all topics we have discussed. Coming to next, perspectives of connecting. So RZI, Manchester, 4B by 5B. So that we had discussed, and framing which we had discussed. What are the different types of frames? How a framing can be done. So bitwise, so stuffing and bytewise stuffing, and how the flag of the things will be used there in both the bitwise and bytewise stuffing. and framing, how it will be done. The starting and ending point of a framing is identified. Error detection methods, which we had discussed already, including error correction, which is a lab program of humming code, which we had discussed, and a sliding window protocols, reliable transmission, which we had discussed clearly. Ethernet and multiple access networks, MAC 802.3, also we have discussed, and we have seen how this particular Ethernet will work. So wireless networks also we had discussed. So coming to the unit 3, then we have discussed switching and bridging, how a spanning tree algorithm will be worked, and what important, how is where the switches will be placed, and how bridging will be done between different networks, like that. So the basic internet working, that is the IP, we have discussed how IP everything regarding that. Then how a routing will be done in a IP. The global internet protocol. That means we have discussed the BGP and XGP, that exterior border gateway protocol and exterior gateway protocol, and routing among the mobile devices also, which we have taken into the considerations, and we had discussed that. Coming to the unit 4, so that is transport protocol. There we have discussed about a UDP, and we have discussed about TCP, especially TCP in depth. We have discussed how a different queuing disciplines will be there, TCP congestion control and congestion avoidance mechanism also we have discussed. Coming to the unit 5, we have discussed the cryptographic building blocks, different types of cryptographic building blocks. So we have discussed symmetric, asymmetric. So in a symmetric DES, triple DES, AES, in a asymmetric RSA algorithm, that is two keys, one public key and one private key, how that will go. Then key distributions, Diffie-Hellman algorithm, which we had discussed, and how a key distributions will be done from one system to the another system, especially in asymmetric cryptography, which we had discussed. And about a firewalls also, we have discussed how a firewall is very important, and how the firewall based on IP and a port, how it will works, we had discussed. And the traditional applications also we had discussed the things, means how a different traditional applications is going to work. So infrastructure services is also discussed in a traditional application. So in this way, the entire syllabus has been covered, 100% syllabus has been covered uh, with this particular text. In this way, I am justifying taking out that particular syllabus. So now we'll end this particular sessions of computer network with this last video, and all the videos starting from I can say from the first chapter to all this particular the fifth module. All the videos are there in a department YouTube channel, and you can view any of the topics, any doubts, anything is there, part means in a view of an exam or a test like that, definitely you can. Thank you very much for your support to complete this particular syllabus. Thank you.